Welcome. This is Geometry A, Unit 4, Lesson 9. We're talking about composition of transformations. Basically, what composition of transformations is when you do more than one transformation at a time. So we might do a rotation followed by a translation, or a reflection followed by a rotation, or any such combination. The lesson does reintroduce the concept of dilation, which is to grow or shrink. Just know this, that if a dilation has occurred, then the object or the image will be a different size than the free image, and congruence is not preserved. And much is made of proving that things are congruent by showing that you can apply rigid transformations, which are translations, reflections, and rotations, to make an exact copy of the image over the free image or the object. In this particular case on the screen, I've got a triangle ABC all up in the second quadrant here, which is negative on the x-axis, positive on the y-axis. And we're going to do a combination of translating by the vector 5, negative 2, and rotating negative 90 degrees. Okay, let me do a little bit of review. Let me hide this here and do a little bit of review of the translation of the mapping rules. Okay, for a translation or a slide, we add the horizontal slide to the x, and we add the vertical slide to the y. Or translating by the vector hk, it's x plus h, y plus k. X-axis reflection, to flip over the x-axis, change the sign on the y. To do a y-axis reflection, change the sign on the x. To do a 90-degree rotation, switch the x and the y and change the sign on y. To do a negative 90-degree rotation, which remember is clockwise, counterclockwise is positive, clockwise is negative. To do a negative 90-degree rotation, we switch the x and the y and change the sign on x. And to do a 180-degree rotation, which, by the way, is also the same as point symmetry or a point reflection across the origin, or also a double reflection x and y axis. They all result in the same thing. We just change the sign on x and y and do not switch the order. There are other transformations, but those are the ones we need to know. Okay. So let's go bring back our drawing here. Okay. All right. So let's see if we can do this here. I'm going to use green here to translate by the vector 5, negative 2. 5 is 5 to the right. Negative 2 is 2 down. So I'm going to go from A, 5 to the right, 1, 2, 3, 4, 5, and down 2. There's A prime, the image of A. And I'm going to do B as well. 1, 2, 3, 4, 5. 1, 2. The image of B is down here. B prime. C, 1, 2, 3, 4, 5. 1, 2. C prime is down here. Okay, and so our resulting triangle is A prime, B prime, C prime. That's after one transformation. Okay, get the triangle drawn here. There we go. Okay, we can see the translation vector by the vector 5, negative 2. Okay, now we're going to translate, to rotate this negative 90 degrees, or 90 degrees clockwise. I'm going to do it visually, but then we're going to double check it with our rule. So V is 2 to the right, rotate 90 degrees clockwise, it's going to be 2 down. So we'll call this V double prime, the image of V prime. Okay, A is 4 to the left, so it's going to be 4 up after rotating 90 degrees clockwise, A double prime. That only leaves C double prime. And you recall the rule is to switch the x and the y and change the signs on 1. So it's 3 to the right and 4 up, so it's going to be 4 to the right and 3 down. C double prime. Okay. And let's take a look at this. There we go. All right, and C. And we get the image after two transformations. Now I want to do a little bit of mathematics on the transformation mapping. Okay, you recall that the rule for translating by the vector 5, 2 is, step 1, xy becomes x plus the horizontal translation, 5, y plus the vertical translation, negative 2. Okay. Step 2 is to rotate negative 90 degrees, so xy becomes y negative x, because that's the rule for rotating 90 degrees. I want to combine these into a single rule, right? Combine these into a single rule. So I'm going to say xy becomes, okay, x plus 5 has this applied to it. We switch the y and the x, and we change the sign on the x. So we switch the y and the x. So this y gets switched, and this x gets switched, and gets negated, changed to a negative. Okay? So the y, which is y minus 2, goes first. And the x goes last, but the x gets changed in sign. So instead of x plus 5, it's going to be negative x minus 5. And this becomes the new function mapping for the combined composite transformation. Okay, and let's try it out. Let's check it out and see if this works. So point A is 2, 4, 6, 8, 9, negative 9, 2. So A is negative 9, 2. Negative 9, 2. And let's see if this works. So I'm going to apply the rule y minus 2. So that's 2 minus 2, because y is 2. And I'm going to apply the rule negative x, negative 9, minus 5. Okay, and let's simplify. 2 minus 2 is 0. Negative 9 is positive 9. Positive 9 minus 5 is 4. So we get A double prime at 0, 4. And that matches the graph. A double prime. Okay, V, let's check this out here. V is at negative 3, 2. Negative 3, 2. Okay, so apply the transformation rule. Y minus 2, so 2 minus 2. Okay, negative x minus 5, negative of negative 3 minus 5. 2 minus 2 is 0. Negative of negative 3 is positive 3. Positive 3 minus 5 is negative 2. So V double prime is at 0, negative 2. There it is. 0, negative 2. And C is at negative 2, comma, 2, 4, 6, 7. Negative 2, 7. Negative 2, 7 becomes y minus 2, so 7 minus 2, comma, negative x minus 5, so negative of negative 2 minus 5. Okay, 7 minus 2 is 5. Negative 2 is 2, minus 5 is negative 3. So 5, negative 3 is V double prime. And whoop, 2, 7. So 2, 4. C isn't 7. C is 6. So that's where I made my mistake. It wasn't matching up, and I knew I'd made a mistake somewhere. So this is 6. So this is 6 minus 2, which is 4. Okay, and that's going to change that here. So 4, negative 3. So 4, negative 3 is C double prime. Yep, I can make mistakes too. All right, 4, negative 3. So it works. Lo and behold, it works. All right, I'm going to split this video in two. We're going to take an existing transformation and we're going to try to come up with a rule that made it in the next video.